Another video with Math and Physics Fun with Gus. Today we're going to be talking about derivatives and basically what they mean geometrically and do some pretty difficult examples doing them. Now I haven't done derivatives in a while, so we'll see if I make a mistake or not. Let's start. Basically I have written down here for you all the three main methods for computing derivatives. We have the power rule here, we have the chain rule here, and we have the product rule at the bottom. And at the very end of the video, we'll do an example that uses both of these. I think people have struggled with those, so that's why I really wanted to do some difficult examples. But first, we're going to get into the geometry. We want to understand the geometry so we can think about derivatives more visually. I think that helps people a lot. So we have a function, y equals x squared, which is the green line here. X squared is this function. And now let's differentiate this. So we see that n in this case is 2. So we do n is equal to 2. And we have n minus 1 is equal to 1. So that means if we differentiate this, we get a new function that's related to the old function by kind of its slope. And we'll get into that in more detail in about a second. So we have here y prime of x is equal to 2x. And that's this line. So that's this line here. So I kind of wrote it down. Now, we're going to look at the slope of the original function here. We want to see how that relates to the derivative. So if we look here at the very bottom here, we see the slope is flat, right? It's not increasing, it's not decreasing at 0. Right, if we draw a tangent line to the original function at 0, we just get a straight line. So if a derivative is really the slope at every point of the original function, if we put in 0 to the derivative function, we should get 0. So let's try it. So we do y prime of 0 is equal to 2 times 0, which is indeed 0. Okay, so let's try another example. Does this actually work? Well, we see here that at x equals 2, the slope is decreasing, right? The function is decreasing. So let's see if we actually get a negative derivative. The function is decreasing, we should get a negative derivative. So we get y prime of minus 2 is equal to 2 times minus 2, which is indeed equal to negative 4. And you can actually see that right here. If we look, we draw a line all the way down here, the value of the derivative is actually minus 4. And then if we do, now we can look here, okay? This is 2, this should be minus 2, sorry about that. We go up, we get a value of 4 too, right? And we see that the slope here is increasing. It's doing the opposite of what it was doing over here. So now we kind of are starting to understand a derivative geometrically, and I encourage you to try more values, maybe different questions, and just kind of look at, okay, how are these related to geometrically, that kind of stuff. Okay, so now let's do some really difficult derivative examples. Okay, so this is the example we're going to be doing. This is 10x times sine of x. And let's now take the derivative. So we want to find h prime of x. So that's going to be equal to, well, let's call this function f and this function g. Right? Because I look at this and I say, okay, there's two functions times each other. So this means we must use a product rule. So we have f times g, the derivative of this, d over dx, of two functions times each other, is what we saw above, which is f prime g plus g prime f. Okay, so if we find f prime, so we know f is this, so f prime is equal to 10. We know g prime is equal to the derivative of sine is cosine of x. Okay, so now let's put this together. We have we have f prime, which is 10. Don't ask me what I was doing there. Times g, which is sine of x, plus g prime, which is cosine of x, times f, which is 10x. Oops, my computer lagged. There we go. So this is the derivative of h of x. Now, if that example wasn't, difficult for you, don't worry. We have a better one coming up. Bam! For this example, we're going to do an example that uses both the product rule and the chain rule. And we'll call this function, let's call it r. It's going to be r of x. R of x is equal to 5x e to the x squared. So I look at this and I see, okay, if I split this down the middle, I have a function here, f. Okay, call this f. And a function here, g. So I know I'm going to have to use the product rule. So let's first get that going. Let's say r prime is going to be equal to f times g prime plus g times f prime. So I see that f, again, is equal to 5x, and that means f prime is equal to 5, and then g is equal to e to the x squared, and oops, that's not like a squared, and then g prime, we'll have to use the chain rule. So I can say g of u is equal to e to the u, where u is equal to x squared. Now if I want to differentiate this, I just differentiate gu, which is equal to e to the u. Now I need to times it by du over dx, right? The derivative of u, which is then e to the u times 2x. And then I can write this nicer by saying 2x e to the u, but u is x squared, e to the x squared. So now let's put this all in. So we have f, which is just 5x, times the derivative of g, which is over here. So it's going to be 2x e to the x squared plus g, which is just e to the x squared, times f prime, which was 5. And now we can simplify. So I'm going to write this one first. 5e to the x squared plus, that's 2 times 5 is 10, x squared e to the x squared. Now I see I can factor out a 5 and e to the x squared, so we have 5 e to the x squared, and that's just itself. For watching, I hope you found this useful. Please leave comments and like, it really helps me a lot.